Hi everybody, welcome to Calculus 2. We will go to section 7.5. Inverse trigonometric function. Of course, we talk about derivative and integral of inverse trigonometric functions. Right, so before we go to the calculus part, let's just review the trigonometry parts. So how do we define a trig, the inverse trig function? So if we have y equal to sine inverse of x, we mean x equal to sine of y. Important that it has to satisfy this domain and range. Right. So when we have that, we will have sine. So if we're going to substitute y equal to sine inverse of x into this, so we have sine of sine inverse. So we substitute this into y, x, and that is equal to x. But it only works if x is between -1 and 1. Likewise, if we substitute here into this x, we will have sine inverse. And now instead of x, we have sine of y. And that equal to y. And it only works if y is between negative pi over 2 to pi over 2. So the domain and range are very important in that. And other than that, if it is in those interval, then the function and the function inverse cancel each other out. Kind of. Anyway, so now if we look at all the domain and range of all of this, we notice there's some similarity here. So the first one we have between -1 and 1. So that is the domain for the sine inverse function. So we try to summarize this information into this table and try to see the common between them. So for sine -1, for sine inverse and cosine inverse, it will be between -1 and 1. So we will write including from -1 to 1. So we just say from -1 to 1. Is the domain of the sine inverse. Right. Next, we have the tangent inverse and the cotangent inverse. For tangent inverse and cotangent inverse, it is between -infinity to infinity. So here we have in between. And for tangent inverse and cotangent inverse, we're going to have the whole line. And then for secant inverse and cosecant inverse, they have the same domain. Absolute values of x greater than or equal to 1, meaning that it is outside of 1. So if we're going to draw that, it is going to be the number line. It is outside of negative 1 and 1. So we will say negative infinity to negative 1, including that union 1 to infinity. It is equivalent to writing absolute value of x squared done equal to 1. Right. So either between negative 1 and 1 on the whole thing or on the outside. So those are the domain for trig function, inverse trig function. And now onto the range. Notice that there will be three kind of range. The first one is between negative pi over 2 to pi over 2. This kind of similar to it too. And kind of have the same thing here too. Right. So, of course now we're going to write that. But why do we need this? Right. So I'm just going to graph the sine function in general. Say sine of x. And then graph. Sine of x is a periodic function. A periodic function cannot be a one-to-one function, but we know that only one-to-one function has inverse. So I try to draw that here. So that is the sine function. We have to restrict the domain. If we talk about the whole graph, when there's one y values, there are a bunch of x values. So if we have three different x values like this, give us one y values. So when we go to the inverse, we don't know which y give us which x we're talking about. So we have to have one x and we have to have one y. So we can go from x to y and then from y to x. So that's why we need the y to y, one-to-one function for the inverse to exist. So in that case, we have to restrict the domain. So if we want to have one x and one y, we will give, for this function, we're going to choose this quadrant, this interval. So we have one x and one y. And within that window, we have one x. Then we will have one y. So, and in terms of the unit circle, this will be negative pi over 2 and pi over 2. I'm talking about the quadrant 0 to pi over 2 is quadrant 1. And negative pi over 2 to 0 is quadrant 4. So for sine inverse, it is in quadrant 1 and quadrant 4. That is between negative pi over 2 to pi over 2. Next, tangent inverse also between negative pi over 2 to pi over 2, but we do not have the equal sign. So I'm going to say it is also in tangent inverse quadrant 1 and quadrant 4. Yeah. But again, there's no equal sign here. So we have that, but no boundaries, no endpoint. So which means we just have negative pi over 2 to pi over 2. Still in quadrant 1 and quadrant 4. And also in quadrant 1 and quadrant 4, cosecant is that. But we don't have the 0. 0 is going to be between this. So once again, it is still in be very careful here. So we have sine inverse, tangent inverse, and then cosecant inverse. In quadrant 1 and quadrant 4. But we do not have the midpoint. Which means we will go from negative pi over 2, including negative pi over 2 square bracket to 0, but not including 0, and then from 0 to pi over 2. Right. So that the reason that all three of this related to each other because we have just trying to find the color highlight. The reason those three are related because sine and then tangent is sine over cosine, and the cosecant is 1 over sine. So the cosecant and sine should be similarity between them. Right. Now, let's talk about the order 0 to pi. So this will be, of course, 0 to pi. So we're talking about quadrant 1 and quadrant 2. So for cosine inverse, we have quadrant 1 and quadrant 2, meaning from 0 to pi. And cotangent inverse also in quadrant 1 and quadrant 2, but there's no endpoint. So tangent and cotangent inverse do not have the endpoints. So it'll be just like this, but no endpoints. And then, and then secant inverse. Secant is reciprocal of cosine, so it could be similar to that also in quadrant 1 and quadrant 2. But will be no midpoint for secant and cosecant. So meaning that we go from 0 to the midpoint, but not including it. And then pi over 2 to pi, now including pi. So, like I said, within this interval, the function and the function inverse kind of cancel each other out. Right. Now, let's go to the examples. Now suppose theta is equal to sine inverse of 2/5, and now find cosine of theta. So we start with that. So let me just rewrite the problem. Theta equal to sine inverse of 2/5. Right. First thing we know that if we're going to have the function and the function inverse cancel each other out if it is in the right interval. So when we do that, we have sine of theta equal to 2/5. Now, this is just trigonometry. We're going to draw a triangle. A right triangle where theta is the angle. Right. Now, this sine is opposite over hypotenuse. So opposite over hypotenuse. And then suddenly we can find the adjacent here. So we know Pythagorean theorem, adjacent square plus 2 squares is equal to 5 square. So and then we suddenly can solve for the adjacent. 5 square 25 minus 2 square, 25 minus 4 is 21. And then we take the square root on both sides. Very important when we take the square root on both sides. We have to have plus or minus. So is that a plus or is that a minus? Right. So we have the adjacent is 21. Now with that we can go back to our problem and we say cosine of theta. Or if we want to, we can cosine of theta, where theta is sine inverse. Of that. Or just cosine of theta, actually is the reason we write like that is because cosine of theta is adjacent over hypotenuse. So adjacent is plus or minus 21, square root of 21. And then over hypotenuse, which is 5. So hypotenuse always positive. Opposite and adjacent could be positive, could be negative. Don't forget there's a plus or minus. Okay. But for somehow most of this problem end up being positive. Right. So how do we determine this? Right. Now let's go back to the table we have earlier. Oh, we still need to key in here. So sine inverse of 2/5. It doesn't matter when we have the sine inverse. It is in quadrant 1 and quadrant 4, right? So notice that this is in quadrant 1 or quadrant 4. Now, think about this. If it is in quadrant 1 and quadrant 4, and we have cosine of it, so cosine of quadrant 1 is positive for sure, and then in quadrant 4, I mean anything, this is the bad notation, but it's going to be positive, right? Because when we talk about cosine is the x values. Anything in quadrant 1 and quadrant 4, x values is positive, therefore cosine is positive, therefore the answer is going to be positive. Right. Of course, we can also do this. Make sure that it is in the radian mode when we do this. So we have cosine of sine inverse of 2/5. It is positive. And is that equal to square root of 21 over 5? Sorry, wrong one. Right. Yeah, they are the same. So when in doubt, we can check and make sure that indeed it is positive. like I said, most of the time, especially if we have a mixture of a blue and a green, so that should end up being positive. Right. Next, find cotangent inverse. Cotangent of cosine inverse of x over 4. So first thing we do is we're going to make inside the inverse function give us the trig function. So we start with let theta be equal to the inside the inverse function. Now to get rid of that, we're going to take the function cancel. And it cancel out. And it is over x over 4. And when we do this, we assume that it is in interval that we can actually do it. So x over 4. So draw a triangle here. Angle theta. Cosine is adjacent over hypotenuse. Adjacent is x over hypotenuse. It's 4. Of course, adjacent x. Right. So this is opposite, which we don't know. So we can use Pythagorean theorem to solve for it. So opposite square plus x square equal to 4 square. So opposite square equal to 4 square, which is 16 minus x square, and we take the square root on both sides. Once again, it is plus or minus square root of that. Right, that's good. Next, we need cotangent of cosine inverse, and the cosine inverse here being theta. So we'll say cotangent cosine inverse of x over 4. That is theta. And cotangent is reciprocal tangent. Tangent is opposite over adjacent. So this will be adjacent over opposite. So we have adjacent x over the opposite that. Right. Now, is this going to be positive or negative? Right. So cosine inverse. What is cosine inverse? Cosine inverse is quadrant 1 and 2. Right. So in that case, we have cotangent of something in quadrant 1 and quadrant 2. That case we don't know, because in cotangent in quadrant 1 and quadrant 2, it could be either positive or negative. Yeah. So cotangent is adjacent over opposite, or x over y, and in quadrant 2 is negative, in quadrant 1 is positive. So in this case we don't know, so we still have plus or minus, and so that is the answer. So it depends on x. If x is positive, this will be positive. If x is negative, and that will be negative. Right. So the x is the answer. There's a plus or minus here. Right. Now, like I said, that's nice and all, but that's just trigonometry. What we focus on, of course, is the derivative and integral. So we have to be able to do something like this. So derivatives of the inverse trig function. I'm not sure if you have to memorize this in calculus 1 or not, but I certainly do not memorize that, because it's always easier if we don't have to rely on the formulas. Right, so we have something like this. So kind of like what we did earlier. If we just take the function on both sides, function cancel the inverse. So that's where we start with. I'm going to take the sine on both sides. Try to write small because I'm not sure how long this problem is. So take the sine inverse on both sides. I mean the sine on both sides. Because the sine cancel the inverse. So I have sine y equal to x squared over 4. I'm going to write that x squared over 4, but we write that as a fraction. How about x squared over 4 over 1? Right. The reason we need that because later on we're going to write that as a fraction. Right. But for now, we're going to do that later. Because now we have to focus solely on that. Right, now let's do some calculus instead of trigonometry. Right, calculus. We find derivative where we have y is the function of x. So from here we write that y is the function of x. When we have y equal to like this, we say y is a function of x. And so when we here we take derivative both sides with respect to x, or we say differentiate with respect to x. So we're going to do that both sides with y as a function of x. So the derivative of sine is cosine. But since y is a function of x, the chain rule applies. We're going to have y prime. So that is implicit differentiation. This count 1. And then we take the derivative of x squared plus 4 on the other side. That is easy, 2x. And now if we want to solve for y prime, it is 2x over cosine of y. The only problem is what is cosine of y? Right. Now that we go back and do the triangle like we did earlier. But I said I want to do that, but that will come later. Right. Now, trying to find cosine of y. Now we will focus on this part here. So we done the calculus. Now we just do the trigonometry. Sine y. Now we write this as a fraction, as a ratio. And sine is opposite over hypotenuse. So draw a triangle. The angle is actually y. So opposite x squared plus 4, hypotenuse 1. We don't have the adjacent. So Pythagorean theorem, x squared plus 4 square plus adjacent square equal to 1 square. So adjacent square is 1 minus x squared plus 4 square, x squared plus 4, sorry, and then square. Right, and then of course we take the square root on both sides. Yeah, that's still plus or minus. Right, that's good to know. But now, is that positive or negative? So I'm going to write cosine of y. That's what we need, right? And y is equal to sine inverse. Sine inverse gives us quadrant 1 and quadrant 4. And in quadrant 1, quadrant 4, cosine is positive. So this is positive. So because of that, we only choose the positive. And that is the adjacent. So back and pick the positive. Right, and finally cosine of y is adjacent that over hypotenuse, which is 1. So we have the positive 1 minus x squared plus 4 squared divided by 1. So that is cosine of y, and we just substitute back in here, and we have 2x over that 1 minus x squared plus 4 square. Right, so that is y is derivative of y. Right. Of course, we can use the formula too, but like I said, it's just trigonometry if we don't have to, if we don't rely on the formula. Right. Next we're going to have this. The difference between this one and that one is there's a -2. So we'll try to get rid of that first. So I'll divide by -2 on both sides. And the first step we say y divided by -2, or we say divide by -2 on both sides. We have cotangent inverse of 3x minus 5. So we have to get the inverse function by itself. Then we can check the inverse on both sides. Right? So, inverse, take the function on both sides. and those two cancel out. So we have that. So cotangent of negative 1/2 y equal to 3x minus 5. Now just like the last problem, we take derivative with respect to x, so we differentiate implicitly. Right, so first, derivative of cotangent is negative cosecant square of something, and then that's something derivative. So that is like the chain rule we did on the first video. And derivative of 2x minus 5, just 3. Right. And then so this stays the same, we cannot do anything with it. This one, derivative of y, just y prime, so we have a negative and a negative, so it will be 1/2, but we cannot do that, sorry. The negative here is inside the cosecant square, so we cannot do anything with it. The only thing we can do is that give us, we still have negative cosecant square of negative 1/2 y. And actually that negative and this negative, that's what we can do. This negative and this negative turn to positive. And then we have 1/2 derivative of y, just that. And then to get to y prime, we divide by the secant square, cosecant square on that side, and multiply 2 on top. So we have y prime equal to, multiply 2 on both sides, 2 times 3 give us 6 on the top. So multiply 2 on both sides, 6, and then divide by cosecant square of negative 1/2 y. Sorry, kind of run out of space there. But divide by cosecant square on both sides. Now, divide by cosecant square, we can just say sine square, right? Right? So we can just give this and we do the cosecant square, or we can just say over cosecant square, move to the top, becomes sine square. Six sine square of negative 1/2 y. Now we get back to this. Now we just find out what is sine and then square that. So now we focus on this, and then so we can go from cotangent to sine. So cotangent 3x minus 5 over 1, and cotangent is adjacent over opposite. Adjacent is 3x minus 5. Adjacent. Opposite. Right, the hypotenuse. So Pythagorean theorem, 3x minus 5 square plus 1 square equal to hypotenuse square. So to get back to the hypotenuse, now the nice thing about hypotenuse is it's going to be positive. We don't have to worry about the positive and negative. If we use x, y, and r, x and y can be positive, can be negative, but r cannot be negative. So in that case, just ignore the plus or minus. Hypotenuse is always positive. So just say square root of that. Right, like I said, we don't need to write in terms of sine square though. We can just do the cosecant square and trying to find out what is cosecant square. But because 1 over cosecant is sine, so I'm going to write like that. And then finally, what is sine? So the angle here actually is -1/2 y. So sine is opposite over hypotenuse. Hypotenuse is that square root. Right, so, and this is sine square, so we're going to square that. Square undo the square root. So we'll have 6. 1 square, cancel the square root or undo the square root. So we do not have the square root anymore. We just have 3x minus 5 square plus 1. Or if we want to write that, it is going to be 6 over 3x minus 5 square plus 1. Right, I realize that's a lot more work than if we just use that formula. However, if we do like this, we don't have to memorize that one. And that's a good practice. Trigonometry, implicit differentiation, and then some more trigonometry, a lot more trigonometry. Right, so that is the first part of it, the derivative of inverse trigonometric function. Now we go to the second part, which is integrals. So, for integral, we have the formulas here. Of course, the proof for that, of course, derived from here. We just do the antiderivative. Just go from here back to that. Right. However, we will do this in section 8.4. So we spend a whole section doing this. So the formula is nice and all, but we don't even need to memorize it. But for now, I assume that we just use the formula. Right. So first we have this, and so in these formulas, A is a constant. And what we need is 3 forms. The constant minus x squared, constant plus x squared, and x squared minus the constant square. Of course, when we have x squared plus a squared, or a squared plus x squared, those are the same thing. but those are the same thing. But when we have x squared minus a squared, that's different than a squared minus x squared. So we have three scenarios, the 1, 2, and then 3. So when we have a constant square minus x squared, so I will rewrite this. By the way, there's a constant here, so just take it outside, and so we will have 4. So we have 1 on the top, just like we need for the formula. And instead of 25, I'm going to write 5 squared. So matching with this formula, the top one, a is equal to 5. And then in the formula, the integral equal to 1 over a. Sorry, I copied wrong one. The top one, the sine inverse, there's no 1 over a. Like I said, I don't memorize this formula. When we go to section 8.4, we can just go ahead and do it without the formula. But we need to know a lot of trigonometry. Right. So that is, in that form, it's going to be sine inverse of x over a plus c. So we have of course there's 4 in front of that, because there's 4 and then sine inverse, and a is 5. So that's all we do if we know the formulas. That's straightforward. Right, next, this we have x squared plus a plus in the middle, so this is the case of the tangent, right? So, but it's not in the right form, so I have to do some manipulation. I moved the x all the way back. So it looks like this because we need 1 on the top. Right, and also in this formula we have a constant square plus x squared, so we need to write that in the right form. So we have, just say 4 plus 9x squared. Right, so it looks like a constant square plus something square. Now, not quite though. In the formula we only have x squared, we don't have 9x squared, so have to get rid of the 9. So to do that, what we can do is try to get rid of the 9. So since it is multiplied by 9, why don't we divide by 9? So multiply by 1 over 9, top and bottom. Multiply across 1 over 9, and the bottom. Four over 9, 9 cancel out, plus x squared dx. Sorry. Now in this we have the x squared. Right. Integral. We need 1 on top, so take that constant outside. And then we need a constant square. So instead of write 4 over 9, we can say 2 over 3 square, then plus x squared dx. Right. What the formula says is going to be that So I'm just write the formula here. Integral of 1 over a squared plus x squared is 1 over a tangent inverse of x over a plus c. And in this case we have a equal to 2/3. So we say this integral and that integral will be equal to 1 over a 2/3, and then tangent inverse of x over a and divide by fraction is multiply reciprocal, so we have 3/2 tangent inverse of x over 2/3 of x times 3/2 multiply reciprocal. Right, so if we can turn into the right form, can use a formula. And this time that's what we do. When we go to section 8.4, then we don't need this formula. But other than that, we stop here because that's the end of section 7.5. Thank you for watching.